That's like Robert says 15. Okay.
Where's the earring?
Up in the closet.
Where?
I can't find it for you right now. It's up in the closet in the corner. Use the chair to go get it.
You got it, or do you need help? You don't look like you got it.
Yeah. Okay. Yeah. Change my mind.
Oh, I'm sorry there.
Hey,
Hey guys, can you hear me?
Yeah.
yeah.
Oh, hello?
I can hear you.
Okay, sorry, my headphones were messing up a little bit.
All right. Does everyone have a group meeting quiz pulled up for lesson 4?
Okay, let me get there. Sorry, I was running a little late, guys.
No problem.
Okay, are we going right into the test?
I'm okay with that.
Yeah.
Okay, and it's lesson 4, correct?
Yeah.
Yep. Lesson 4 group meeting.
Okay. How'd you guys do on the quizzes? Yeah, I got like an 86 and a 70. I couldn't remember the week before. I'd waited too long. I should have done it sooner. Sorry, I'm having troubles finding it. Here we go. Okay, I am all ready to go.
Do you want me to start?
Yeah. Go for it.
Okay. All right. So number 1 says use the following information to answer the next 3 problems. Human blood can be classified into one of this is supposed to say 4 basic, or O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following table. Blood type O, 45% or 0.45. Type A, 40%. Type B, 11%. Type AB, 0.0, or I guess that's 4%. Sorry. Okay, so question. Wait. Okay, so question 3. Sorry. The blood types and the proportions given in the table above define a probability distribution. True or false?
Okay.
I would say false because they add up to more than 1.
Yeah. I don't remember probability distribution, that term specifically.
Mine. Mine. Mama. Mine.
Yes. Okay, so the probability distribution, like with those, do you remember like when they talked about the rules of probability?
Mhm.
Where's the assignment? Sorry. So like in the preparation assignment in part 1, number 2, it says please state and describe 3 rules of probability. You can determine whether it's a probability distribution by seeing if it follows those rules. That makes sense. Somebody say they didn't understand. Sorry, my daughter was talking.
Yeah, you're good. Yeah, I was just I didn't understand, like, because I didn't remember that in the reading. But yeah, I think you said it was true, right?
No, she said it was false, I believe.
Oh,
It's false. Because like the rules are like that probability of any event has to be greater than or equal to 0 and less than or equal to 1. So it has to be between 0 and 1 because that's like equal 100%.
Okay.
So like, and then
Okay, that makes sense.
have to equal 1. So like if you have all of the probabilities together, it has to add up to 100% or add up to 1. And then this one,
It does add up to
It-
1.
doesn't add up to more, 45. Because 0.45 plus 0.40 is already
85
Oh, wait,
plus
wait.
15 is 1.
Oh,
So
good.
that would mean
Okay,
it
good.
was true then. So you understood it.
Yes.
It's just
True.
the mental
Just
math.
my math.
Mental math is killer.
Yeah. Are you ready for question 4?
Yeah, I feel good about that.
What is the probability that a randomly selected person in the United States has type O blood round to 2 decimal places?
I guess 45%.
Yeah, it sounds too easy, but I don't know what else it could be. That's asking.
I mean, it makes sense. It says round to the nearest decimal place, so I guess just point
That
0.45.
does seem
Yeah, no, that's right. Because a proportion is just bits and pieces, and if it's out of 1, that means it'd be 45% or 0.45.
Yeah, that makes sense.
Okay. Everyone feel good about that? Awesome. I'll read number 5. What is the probability that a random selected person will not have type O blood? Round to the nearest the 2 decimal places.
So it's just 0.55 then, because everybody that doesn't have that.
Mm-hmm.
Yeah, that makes sense.
Okay, and then I can read the next one as well. Does everyone feel good about that? 0.55? Okay. Caroline Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowels containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. Question 6. If a dog guesses at random, what is the probability that they will correctly identify the dish containing the specimen from a bladder cancer patient? Round answers to the 3 decimal places. Okay, so divide 100 by 6. It says point. Sorry, my mental math is terrible. It's 16.667 is what I got for the probability.
Wait, can y'all hear me?
Oh, now we can.
Okay, so my headphones were in the wrong spot. You wouldn't divide 100 into 7. You would divide 1/7
Yeah, it's 1/7. That's all.
Oh, so okay.
because you have the 7 possibilities, and one of them has one of them has cancer. So you would just do 1/7.
Okay.
So it should give you
So
something like 0.143.
Yeah. But do we round it to 2 decimal places? What is it?
Round to
3? Yeah, so 0.143 then. That's what I got.
yeah, that's what I got. Man.
Sorry, we didn't realize your headphones weren't working.
Yeah, I
Yeah,
thought
it's
they were,
like
but I'm
quiet today.
yeah, sorry. I thought they were working.
Do you agree with everything that's gone on then, I guess?
Oh, yeah,
You
yeah.
didn't really have a say.
Yeah, everything's been right so far.
Okay.
I rate 7. In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? This provides strong evidence that dogs can detect bladder cancer, or this is little evidence that dogs can detect bladder cancer.
Perform trials.
That's basically like 50, a little less than 50%.
So I would think it'd have to be little evidence if they can't even do it half of the time.
I agree.
Just going probability wise, like what we're supposed to be learning. I don't know.
That's not probable. It's possible, but not probable, I guess.
Right. So you can't. There's no way you could say strong evidence if they. So it has to be little evidence, right?
I would agree.
Yeah.
Yeah, that makes sense.
Okay, I can read the next one.
Okay, I can read the next one. Go ahead, Heather.
Okay. It's my turn now. Okay. Okay. Use the following information to answer the next three questions. M&Ms are small chocolate candies. The M&Ms website in the United States. The distribution of colors in a bag of plain M&Ms is given in the following table. Brown 13%, yellow 14%, red 10%, blue 24%, orange 20%, and green is
Covered up.
2, 4, 5,
Is
6,
that right?
7.
Oh, because the green is only in certain bags, right?
Green is blue.
Okay, no green. I think that's what they mean by that. Reach into a bag of plain M&Ms. What is the probability of drawing a red colored candy?
Yeah, that's just 0.13.
0.13. So the probability, the proportion of green is 0.16.
Yeah, that's what I got too.
Hey, look, that's the next question.
So question 9.
Yeah.
Oh.
We don't like those.
Oh,
blanks.
that's why. I see.
Yeah, I wanted to make sure that we could solve them.
Okay.
And then if it's not green, it's 0.84.
Yeah.
Yeah.
Nice, that was easy. I hope that was easy.
Yeah, I can read. Everybody good so far?
I'm just
Mhm.
making sure I get the same. So you said green was. Sorry, what was the answer?
0.16.
Okay. Sorry, I'm just trying to not. So just a second. Sorry. Sorry, my phone's usually my calculator, but right now it's my camera, so my computer is taking me long. I should use Excel. Sorry. Okay, so all you do is add up, right, and then subtract that from 1. That's
Yeah.
what you did?
Mm-hmm.
Okay, awesome. 0.16?
Yes.
Good. Okay, sorry. Must have been missing a number. Okay, so it's not green, 0.84. Okay. Okay, sorry. You can keep going.
Okay. So for the next three questions, the ACT scores of students admitted to a medium-sized public university in the Western United States were taken from Capix.com. The following summary statistics were calculated. And it gives us the table. Half of the observations are less than or equal to what number? So this is just a review. Wouldn't it be 24.3, or is it just a straight 24?
Where'd you get the 0.3?
So it gives you the mean at the top, which is 24.3, and then it has I guess the median is the middle, so it would just be 24.
Yeah, that's why. Because I was thinking of which one it would be, but like when you think about it on the line, it would have to be the median.
Yeah, because the mean takes the average.
Mhm. I like that.
Okay. Yeah.
Question 12. Based on the information on the table above, the top 25% of the students scored above what number? So that should be above Q3, so above 27.
Yeah, that's what I think.
27, I agree.
And question 13. Which of the following statements is not one of the 3 rules of probability? The probability that an outcome will occur is 1 minus the probability that it will occur. A probability is a number between 0 and 1. If the probability is high, then the probability is positive. If the probability is low, then the probability is negative. The sum of the probabilities in any probability is 1.
That's
It's
the one.
the high one. High and
The
negative.
positive and negative
The
one.
last one.
Yeah. C. Yeah, if it was like A, B, C, D, A, B, C, if the probability is high, the probability is
Yeah.
positive.
Oh.
Yeah, because
I just don't understand the wording of the last one.
it's just saying that the sum of all the different options
Have to
is
equal 1.
1. Yeah.
Yeah, it's just like question 1, how like they all have to add up
Okay.
to 1.
Yeah. It took me a second to read it and try to figure out what it was saying too.
Probability is in any probability. That sounds weird to me.
Yeah, but you had explained that to us. I didn't get that before you had explained it, so the wording is weird. But I actually learned that from you. So.
Yeah.
Awesome.
But no, I feel good about that.
Yeah, me too.
All right, let's submit.
Okay. Awesome.
Who's the scapegoat? Whose fault is it if we get it all wrong?
I'm going. Oh man.
We're
We're
7. Dang it.
What? Which one did we miss?
7.
That would be
Oh.
easy to redo though.
Yeah, that's an easy fix.
It's out of 2 options.
Huh?
Yeah, I was wondering
That's
after we
strong
did
evidence,
that
huh?
that if it was strong evidence or not, and I was like, oh.
I didn't think so, but
Is that in the textbook? Like, as far as what qualifies as strong evidence? Maybe.
I don't remember it, but
yeah, easy fix. So
Oh, what's 1 over 7? 14.3, is that what it is? Yeah.
So 7 was the only one we got wrong.
Mm-hmm.
So are we redoing it?
I'm going to.
yeah, me
Yeah.
too.
Like, our score doesn't get deducted or anything for redoing it, right?
no,
No.
they take the higher of the 2.
The green candy was 16, right?
Yeah, 0.16.
And then 0.84 was everything else.
0.84. Yeah.
I'd be so mad if I screwed something up.
Right?
Yep, there we go. Got 100 now.
Love it when our teachers let us take them twice. So
What was
nice.
that decimal for 1/7?
It's 0.143.
Yeah.
Okay, that's what I thought.
So what is defined as strong evidence then? I don't remember that being in.
Yeah, I don't remember it either. Well, I guess, what, 54.
I kind
So-
of remember it from Math 108, like a little bit them talking about but I don't remember like actually what the answer is, but I remember them talking about like what constituted like a legitimate evidence of something, like a study worked
It's
or
probably
whatever.
it's probably like it has to be, I want to say it has to be like higher than the observed, like what it should be. So out of like 54 attempts, he should get it like every seventh or eighth try. I
Or
want to
is
say
it, like,
something like
because
that. It's
Higher
bigger than the
1/7,
probability.
maybe?
I think that's what it is, 'cause that's the only thing that makes sense that I can think of.
Just higher than the probability.
Because the probability of it being random,
Is 1/7, and he
so
has.
like if they do it randomly, it would be 1/7, and since it's higher than that, then
Yeah, but I feel like it has to be like, you have to have more information. You have to have like the standard deviation and everything. Just not the, oh, he got really lucky.
Mhm.
Yeah, I guess that makes sense.
Yeah. We'll know that for the quiz now.
Right?
But, okay. Well, I guess is there anything else, or do you think we feel pretty good about all that?
I'm good.
I think we're good. And then tomorrow we just need to meet again for the next.
Mm-hmm. And I think this one has to be posted on the group message, right? Or
Oh yeah.
the group
You
chat.
recorded it? Somebody record it?
Yeah. I have the link and I can post that in here actually right now. I was looking at that real quick.
Sweet. That'd be great. I guess, do you just put the link in, or do we all put the link in? Do you know?
Yeah, I think just one of us has to. I'm looking at it right now. It looks like, wow. Yeah, looks like just one of us has to.
Okay. Then you're planning on doing that then, to put that in?
Yeah. Mm-hmm.
Okay, perfect.
Good enough.
We should be good.
Thanks.
Does tomorrow at 1 or 2 or I'm trying to think. You guys are
1:45.
Mountain Time, yeah. 1:45 work, right?
Yeah, that's good.
Okay, sounds good. See y'all then.
Yeah. See ya.
See ya.
Thanks so much.